Assalamu alaikum warahmatullah. Now we move on to OFDMA, which is the multiple access technology based on OFDM. So here you have the frequency axis and you have the time axis. Here you have the symbols in the OFDM symbol, okay? And you have here the subcarriers. So as you can see, we have a grid, a time frequency grid, okay? Those subcarriers are reserved for frequency estimation, for channel estimation, and the rest can be given as resources to the users. So multiple users can use the same grid, and you can give them different blocks, more resources depending on their need. Okay, so you can assign them adjacent subcarriers, or maybe you can assign them random uniform subcarriers. This would be beneficial to combat frequency problems in the grid, right? Or you can assign them regularly spaced subcarriers. Okay, so this will give you frequency diversity, and random assignment can give you as well more robust frequency diversity. Of course, the OFDM and OFDMA technologies, they have challenges. Nothing is perfect. The main two problems are the peak to average power ratio problem in the OFDM and the frequency and timing offsets. So the power problem says that, okay, you have a given average and you have the peak value. So this ratio is too high in OFDM systems. So what would this thing leads to? Of course, in the digital domain, it's not significant, but when you move on to the analog domain, you have to amplify the signal. You have to pass it to a power amplifier. The power amplifier has a linear region, right, and non-linear region. So usually the power amplifier works in the average, around the average value of your power, right? But if you cross that linear region here to the non-linear region, meaning maybe some peak value will cross that threshold, then the output will become distorted. So you will be distorting the output, meaning that you'll be producing harmonics and artifacts that might affect adjacent bands. So what you have to do by law is you have to back off. So you have to reduce the power amplifier gain. This leads to that in this case, the output power of the power amplifier is reduced, hence the coverage radius or distance is reduced, leading to more cost in the system. So this is a major problem. So the power is defined as the maximum over the minimum power, right? And usually the power for the OFDM is proportional to n, to the number of subcarriers, which is very large, and goes to sometimes to 1042 48, sorry, right? So it's a very large number. Okay, so you need to back off, reduce the output power. Frequency and timing offsets, you have to estimate the frequency offset very accurately, otherwise the subcarriers will not be orthogonal and they will interfere with each other and cause degradation in performance. So as the same thing applies to the timing offset, you have to estimate the beginning and the end of the symbols so that the symbols within the same OFDM symbol will not interfere with each other and destroy the orthogonality.